January 2019, question 9b. It says, a person at the top of a lighthouse, TB, sees two ships, S1 and S2, approaching the coast as illustrated in the diagram below. The angles of depression are 12 degrees and 20 degrees respectively. The ships are 110 meters apart. I says that we must complete the diagram below to insert the angles of the angles of depression and the distance between the two ships. So we are told that the distance between the two ships is 110 meters. So we'll put that in. The angle of depression of S2 is 12 degrees. And the angle of depression of S1 is 20 degrees. Put those in. Now this is the horizontal. Alright, we didn't put that in. We're not going to get a mark for that. But I just wanted to use that to explain. Angle of depression is the angle between the horizontal and the line of sight when you're looking down. So someone is at T, the top of the lighthouse, TB, is at T and is looking down at S1 and S2. So these two lines here would represent the person's line of sight. Now, the angle of depression is the angle between the horizontal and the line of sight when you're looking down. So to illustrate the angle of depression, you start at the horizontal and then you draw your curve until you come around to the line of sight. And the angle between the horizontal and the line of sight when looking down is the angle of depression. All right, the second thing we must do is determine to the nearest meter the distance T(S2). We're to determine to the nearest meter the distance T(S2). So this is the line they want us to determine the distance of. All right, to do that, I'm going to determine this. I'm going to use this information from this triangle here. I'm going to use information from that triangle there. Triangle T, S1, S2. All right, so let me erase those lines. So this is the triangle I'm going to use. I'm going to use triangle information from triangle T, S1, S2 to determine the length of the line S, T, S2. All right, now let's look at the information that I have. So far, the only information I have about this triangle is the length of the line S1, S2. The length of the line S1, S2 is 110 meters. I can easily determine the size of this angle here. I'm going to call it theta. So I can easily say that the angle theta is equal to 20 degrees minus 12 degrees, and that angle is equal to 8 degrees. So this angle here, theta, is equal to 8 degrees. Now, I could determine this angle here. I'm going to call it alpha. Now, alpha is equal to 20 degrees alternate angles. Alpha is equal to 20 degrees alternate angles. So this angle here is 20 degrees. Now, if this angle here is 20, it means that this angle here is 160 degrees. This angle is 160 degrees because they're angles on a straight line. So let's call it beta. So beta is equal to 160. So I can say that beta is equal to 180 minus 20 is equal to 160 degrees. They're angles on a straight line. They're angles on a straight line. Alright, so now I should have enough information. Now for the triangle T, S1, S2, I know the size of two angles and one side. If I know the size of two angles and one side of a non-right angle triangle, that is a condition for applying the sine rule. So with sine rule, whatever I want, I'm going to start with. So I want to find x, I'm going to start with x. So it's x over the sine of the angle opposite from the side x. And the side opposite to the angle, the side S is 160 degrees. So this is 160 degrees. And this is equal to the 110 meters. 110 meters divided by the sine of the angle opposite to that side, which is 8 degrees. All right, I'm going to bring this over here and say that x, which is t s2, would be equal to 110, the sine of 160 degrees, divided by the sine of 8 degrees. So let's figure that out. So it's 110, the sine of 160 degrees, divided by the sine of 8 degrees. And let's see what we get. So this says the length of this line is 270, and that is meters, and this is to nearest meter. This is to the nearest meter. All right. All right, let's see what is the next thing that asking us to find. So let's just put that in there. So the length of this line here is 270 meters. All right. The next thing they want us to find is they want us to determine the height of the lighthouse. So let's call the height of the lighthouse y. All right. I'm going to use, in order to find that, I'm going to use triangle TBS2. So the first thing I'm going to do is identify the size of this angle here. All right. Let's call it gamma. Now gamma is equal to 12 degrees. That angle there is equal to 12 degrees. And again, alternate angles. Alternate angles, sometimes referred to as Z angles. All right. So if the angle up here is 12, the angle down there is 12. They're alternate angles. All right. So then I'm going to say the side y is opposite. The side y is opposite to the 12 degrees. And x, the 270 centimeters, is the hypotenuse. All right. So let's put all that on paper now. So I'm going to say that gamma is equal to 12 degrees. They're alternate angles. Then I'm going to say the sine of gamma, which is 12 degrees, is equal to the opposite side y over the hypotenuse, which is 270 meters. If I have one fraction is equal to one fraction, I'm going to cross multiply. So 1 times y is y. Y is equal to 270 times the sine of 12 degrees. So y, which is the height of the lighthouse, TB, is equal to, so it's 270, the sine of 12 degrees. And the height of the lighthouse, TB, is 56 meters, and that is to the nearest meter. All right, so that is B. This is B. Alright, let us see if there is a C. Alright, there is no C. So that seems to be the end of the question.